Hello students, welcome back to my channel. Today's topic is coordination compounds. It is one of the most scoring and concept based chapter. So today we are discussing very important previous year questions. So now try to solve the questions along with me. Now coming to the first question, list 1 they given, list 2 they given, list 1 and list 2. So in the list 1 they given the transition metal ions. So first one is the Ti plus 3, second one is the vanadium plus 2, Ni plus 2 and scandium plus 3. So transition metal ions means D block elements metal ions they given. Now spin only magnetic momentum, so mu value they are asking, mu value how much. So this side they given the mu values. So now what are the metal ions they given? Titanium, vanadium, nickel and scandium. So now how to calculate the magnetic momentum, spin only magnetic momentum, how to calculate? So first one they given the first option, they given the titanium plus 3, they given titanium plus 3. So how to calculate the mu value? We are calculating the mu value. Mu means what is that? Spin only magnetic momentum. We have to calculate for each and every ion, we have to calculate. Now titanium is the D block element. So D block element, its atomic number is 22. Atomic number is 22. So configuration, if you are writing here, argon is the noble gas. So argon totally 18 completed, 18 electrons are completed. Next remaining 4s2 and 3d2. So this is the titanium configuration. Now what they given ion? Titanium plus 3 they given. So titanium plus 3 means what is that? Titanium is loosed 3 electrons. So what is the configuration of that? Here totally in last shell, this is the fourth shell. So fourth shell totally 2 electrons are there. In before shell also, in 3D shell 2 electrons are there. Now how many we have to remove? Means 3 electrons we have to remove. Then first we have to remove the electrons from 4s shell. So electrons remove, 2 electrons remove, then it will be 4s0 and this will be 3d1 this is. So titanium plus 3 configuration is argon 4s0 3d1. So d orbital, totally d orbitals, 5 d orbitals are there. So 5 d orbitals means in this dxy, dyz, dzx and dx square minus y square dz square. So these are the 5 d orbitals. So in the electrons are there, one electron only is there. So remove, fill in the 3d orbital. So that is one electron in the 3d. So how many unpaired electrons are there? Unpaired electrons we are represented by n. So unpaired electron is the 1. So unpaired electron is the 1 means actually mu formula, we have to calculate the mu, that is the magnetic momentum, spin only magnetic momentum, that is the root over n into n plus 2. So this is the formula of that, n into n plus 2. So substitute n value on that, 1 into 1 plus 2. So that is how much? That is 1 plus 2, 3, 3 into 1, root 3. So this value is the root 3. Root 3 value how much? That is nearly 1.75. Magnetic momentum mu value how much for the titanium ion? That is the 1.75. So this is the titanium plus 3 ion magnetic momentum. So next what they given? That is the vanadium plus 2 they given. So vanadium plus 2. Second one is the vanadium plus 2. So vanadium atomic number how much? That is the 23. So configuration right now. So what is the configuration? Argon is the 18. Next 4s2 3d 3 will come, 3d3. So this is the scandium, titanium, vanadium. So vanadium is the 23. So this is the configuration argon 4s2 3d3. So now this is the vanadium configuration. This is vanadium configuration. Now we want vanadium plus 2. So vanadium plus 2 means how many? It loses 2 electrons. So that's why argon 2 electrons remove from 4s orbital, then 4s0 and this is the 3d3. 4s0, 3d3. So now 3d orbital, totally 5 d orbitals are there. Then how many unpaired electron? Totally 3 electrons are there. According to Hund's rule, fill that 1, 2 and 3. So how many unpaired electrons are there? N equal to 3. So n equal to 3 means mu value directly we can write nearly equals to 3.75. 3.75. Here n equal to 1 means unpaired electrons are 1. Mu value directly we can write 1.75. No need to substitute in the formula. Directly shortcut method, that is the n equal to 1, mu value is the 1.75. N equal to 2, that is mu value is the nearly 2.75. N value is the 3, mu value is the 3.75. So this is the vanadium plus 2 value is the 3.75. Next, third one, they given the Ni plus 2, they given Ni plus 2, nickel plus 2. So nickel atomic number is 28. So nickel configuration, how much, what is that? Argon is the 18 and 4s2 and 3d8. So this is the nickel configuration. They given the Ni plus 2 configuration. Ni plus 2 means we have to remove the 2 electrons. So remove the 2 electrons from the 4s orbital, then argon, next 4s0 and 3d8. So this is the configuration of Ni plus 2. So now in 3d orbital, how many electrons are there? 8 electrons are there. So now fill in 5d orbitals, totally 5d orbitals are there. So in this 5d orbitals, we have to fill the 8 electrons according to Hund's rule. Then if you fill one electron, we have to fill 1, 2, 3, 4, 5 and again pairing 6, 7, 8. So totally now how many unpaired electrons are there? 2 unpaired electrons are there. So n equal to how much? Unpaired electrons are 2. Then mu value directly we can write, that is the nearly equals to 2.75. 2.75. So that is the Ni plus 2 spin only magnetic momentum. And after that they given the scandium plus 3. Scandium plus 3 ion they given. So first of all, write down the scandium configuration. Scandium atomic number is 21. So configuration is argon 4s1, sorry 4s2, 3d1 is the configuration of scandium, but they given scandium plus 3. So plus 3 means what we have to do? We have to remove the 3 electrons. So that is the, so 3 electrons, first to remove the electrons from 4s, then it will be 4s0 and one more electron from 3d, so 3d0 also. So there is no electrons in the d orbital, then and unpaired electrons are 0, then mu value is also 0. So these are the mu values. So titanium plus 3, how much we got? That is the 1.75. Titanium plus 3 is the 1.75. 1.75. So now match that. And next one, scandium plus 3 we got 0. And vanadium plus 2, how much we got? Vanadium plus 2 we got 3.75. 3.75 nearly equals to 3.87. Next, Ni plus 2, it is a 2.75. So nearly equals to 2.84. So this is the answer for this question. Next, coming to the second question. Here they given one of two lists they given. In one of that complex compounds they given, and here hybridization they are asking. So now coming to the first option, what they given, that is the K2, what is that? K2 NiCN4. NiCN4. So this is the compound. Now we have to calculate hybridization of the central metal atom. We have to calculate. So coming to, first of all, calculate the central metal atom is the nickel. So first calculate the oxidation states. So now K2, potassium oxidation state is 1. Why? Because it is a 1A group element. So 2 potassiums are there. So 2 into 1 plus nickel we don't know. So put the X plus 4 cyanide ions. So 4 into each cyanide ion charge is the -1 equals to 0. So totally it is a neutral compound, so equal to 0. Then x equal to how much you will get? This is the 2 and this is the -4. Then x minus 2 equal to 0. X minus 2 equal to 0. Then x equal to 2. So nickel configuration, nickel atomic, sorry, oxidation state how much? That is the +2. So now again write on the configuration of Na+2. Nickel is the 28 atomic number. Nickel, write down the configuration. Nickel configuration is the argon 4s2 3d8. This is, now we have to write Ni+2 configuration, then remove the electrons from 4s orbital, then argon 4s0 3d8. So this is the configuration of Na+2 configuration. This is, now here 3d8 means totally how many d orbitals are there? 5 d orbitals are there. Totally 8 electrons we have to fill. But here ligand is the cyanide ion. Cyanide ligand is the, cyanide is a strong field ligand. Cyanide ion means cyanide ligand is a strong field ligand. So strong field ligand means what will happen? Pairing will be takes place. So we have to do the pair up. So totally 8 electrons we have to pair up these 8 electrons also we have to pair up. So 1 2 again 3 4 5 6 7 8. So one d orbital is vacancy is the next to 3d8. After that 4s0 and 4p0 also is remaining. Then 1s orbital and 3p orbitals. Now 1 d orbital is remaining, then 1 s orbital and 2 p orbitals are involving in the hybridization. Why? Because it is a coordination number 4. So it is a, what is the hybridization? dsp2 is the hybridization. Coordination number 4 means totally 4 vacant orbitals only have to be. So 4 vacant orbitals we have to do, that is the dsp2 hybridization. And next one, second one, the given ni CO4, NiCO4 they given. What is the hybridization of this? They are asking. So now first of all, what is the central metal atom? That is the nickel is the central metal atom. Now we have to calculate the oxidation state. So nickel oxidation state is X and CO is charge is 0. So totally 4 CO equal to 0. So X equal to 0. So nickel, what is the oxidation state? 0 only. So we have to take the ground state configuration only. So what is that? Nickel atomic number is 28. So argon 4s2 3d8. 4s2 3d8. This is the configuration. Here carbonyl is a strong field ligand. This is CO is also carbonyl ligand is a strong field ligand. So here different pairing will be. So here from 4s orbital 2 electrons also shifted to 3d orbital. Then it becomes like a 4s0 and 3d10 will be 3d10 will be. So 3d10 means totally 10 electrons also filled in the 5d orbitals. 5d orbitals totally fulfilled. So 1 2 and 3 4 5 6 7 8 9 10. So totally there is no vacant d orbital. Then 4s0, after that 4p0, then 1 s orbital and 3 p orbitals. So out of 1 s orbital is vacant and 3 p orbitals are vacant, then 1 s orbital and 3 p orbitals are intermixing and forms 4 sp3 hybrid orbitals around the nickel. So what is the hybridization of nickel? That is the sp3 hybridization. Next one, they given CO NaH3 6 Cl3 they given. So in this central metal atom is the cobalt. So cobalt oxidation state calculate. So first cobalt oxidation state we don't know. So X. Next Each ammonia is the 0 charge only, so totally 6 ammonias, so 6 into 0 plus each chlorine minus 1, so 3 into minus 1 equal to 0. So x minus 3 equal to 0, so x equal to 3. So that is the oxidation state of cobalt. So cobalt plus 3 is the oxidation state. So now write down the configuration of cobalt plus 3. Actually cobalt is the atomic number is 27. Now normal ground state configuration, that is the argon. Cobalt configuration is the argon. 4s2 3d7 is the configuration of cobalt. Now cobalt plus 3 configuration. Cobalt plus 3, how much that is? We have to remove the 3 electrons. So remove the 3 electrons from 2 electrons from the 4s orbital and 1 electron from the d orbital. Then cobalt plus 3 configuration, how much? That is the argon 4s0 and 3d6. So totally 3 electrons we remove. Now ammonia is a, it is a strong field ligand. So strong, what is this? Ammonia is a strong field ligand. So strong field ligand means what will happen? Pairing will be takes place. Pairing will be takes place. So now 3d6 means totally how many d orbitals are there? 5 d orbitals are there. Next d, how many electrons are there? 6 electrons are there. But due to the ammonia strong field ligand, pairing will be takes place. Then 1 2 pair up. Next 3 4 5 6. So totally 6 electrons we filled. After that, which is empty? 4s orbital. 4s orbital is also empty. This is the 4s orbital. These are the 3d6 3d orbitals. Next after that 4p is also 4p. This is the 4p orbital. 4p also 4p 0 only. So now here this is the coordination number 6. So coordination number 6 means we need totally 6 vacant orbitals we need. So here how many vacant orbitals? 2 d orbitals are vacant, so d2, and 1 s orbital d2. Next totally remaining 3 p orbitals we need. So that's why what is that? 3 p orbitals. So totally d2 sp3 is the hybridization of CO NH36Cl3. So this is D2sp3 hybridization. And next one, fourth one, Na3COF6 they given. Na3COF6. Now in this central metal atom is the cobalt. So cobalt oxidation state calculate. So 3 sodiums, each sodium charge is the +1. So 3 into +1 plus cobalt oxidation state we don't know, so put the x. Next plus 6 fluorines are there, so 6 into each fluorine is the -1 equal to 0. So now x, this is the +3, this is the -6, so x minus 3 equal to 0. So x equal to 3. So cobalt, what is the oxidation state? +3 oxidation state. So now cobalt, what is the atomic number? That is the 27. So 27 means configuration is the argon 4s2 3d7 is the configuration of cobalt. Now cobalt +3 configuration, that is the remove the 3 electrons. So first remove the 2 electrons from the 4s orbital, then it will be 4s0 and this is the 3d6 will come. So this is the cobalt +3 configuration. Now here totally how many electrons are there? 6 electrons are there. So totally 5 d orbitals are there. So within 5 d orbitals we have to fill the 6 electrons. But here what is the ligand? Here fluorine is the ligand. So fluorine is a weak field ligand. It is a weak field ligand. So no pairing is takes place. So totally d electrons, d totally 6 electrons also fill it like a Hund's rule only. So 1 2 3 4 5 and one more electron here pair up. So there is no vacant d orbital. So 3d orbital is no vacant orbital. So remaining which one is the 4s0 is a vacant orbital and 4p0 also 4p0 and 4d0 also vacant only. So now it is a coordination number 6. So totally it is a coordination number 6. So we need totally 6 empty orbitals. Why? Because ligand is donating lone pair. So central metal have to get the vacant orbitals only. Totally it needs 6 ligands are giving 6 lone pairs. So it needs 6 vacant orbitals. So one s orbital is vacant. Next 3 p orbitals also vacant and 2 d orbitals. So outer d orbitals are involved. So this is the sp3 d2 hybridization. Yeah, inner d orbitals are no vacancies there. Electron is there. So no vacant d orbital. So inner d orbitals are not involving in the hybridization. Here outer one s orbital and 3 p orbitals and 2 d orbitals. Outer d orbitals are involving in the hybridization. So totally this is the sp3d2 hybridization. So this is the answer for these questions. Thank you.